Okay, so let's talk about chapter 6.6, which is solving trigonometric equations. And in fact, we're going to have to do this in three parts. We're going to first talk about being able to solve some very simple trigonometric equations over a closed interval. And next, we'll take it to another level by looking at solving over some open interval, like negative infinity to positive infinity. And then finally, we want to be able to solve more complex trigonometric equations over a closed interval. And so it's going to take us a couple of steps here to get to what we want, but that's what we're going to do. So let's first consider an equation like this one. We've got sine of x is equal to 1/2, and we want to look for all of the values x for which that occurs over the interval from 0 to 2 pi. So we think about this for a minute. We say, well, if we're looking for the values of x, whose sign would be equal to positive 1/2, now the positive and negative makes a difference right here, then what we're really looking for are angles that end in the first quadrant and in the second quadrant. So now let's think about how we can get one of these angles in the first quadrant. As we learned in section 6.5, the inverse trigonometric function will give us that kind of value. Remember, the inverse trigonometric function is the kind of function that says, well, if the sine of x is equal to 1/2, then to find x, we'd be taking the inverse sine of 1/2. And the inverse sine of 1/2 is going to be an angle that's only in quadrant 1. We're looking for the kind of angle that would give us the ratio inside of a right triangle whose ratio of opposite to hypotenuse is equal to 1/2. And we happen to know what that one is. That is the angle pi over 6. And that's fine for the first quadrant because that's the kind of thing that we're looking for. We're looking for the kind of angle that would give us that. But what about quadrant 2? Pi over 6 is not that angle. Well, in quadrant 2, what we're going to do is we're going to take this first angle that we found, pi over 6, and we're going to use it as a reference angle. So we're going to draw our right triangle this time in the second quadrant. Right? We always reference to the horizontal axis right here. So if we put pi over 6 right here, we're looking for the standard position angle whose sign would be 1/2. And so we can say, well, let's take pi and subtract the angle pi over 6 and see what happens. And in this case, that turns out to be the angle 5 pi over 6. And so the two angles, the two solutions to our equation is contained in the set pi over 6 or 5 pi over 6. And these are the two values on the interval from 0 to 2 pi that make the equation true. Well, that's very straightforward. And if we have a nice basic equation, all we're really doing is we're just stepping back to the same kind of thing that we've been doing all along. But what makes this section a little bit more interesting is that we start getting equations that look kind of like this one. 4 sine squared x minus 1 is equal to 0. What could we say about it? Well, really, in this case, we could just carry out some basic algebra to isolate the sine by taking 4 sine squared x minus 1 and adding 1 to both sides to get an equation that looks like 4 sine squared x equals 1. Dividing both sides by 4, so we get the sine squared x is equal to 1/4. And then taking the square root of both sides. Now we do need to be careful right here because when we take the square root on both sides, recall that we have to get the positive and the negative root of the value on the other side. So in fact, we're going to end up with two equations out of this. In one form of the equation, we're going to get sine of x is equal to the positive square root of 1/4. Well, that's 1/2. But in another case, we're going to get sine of x is equal to the negative of the root of 1/4. That's negative 1/2. Right. So as we stated in the last problem, we know what happens. Quadrant 1 and quadrant 2 will give us two separate values for the sine of 1/2. One was at pi over 6, and the other one was at 5 pi over 6. But what about the other quadrants right here? Well, if we go back and we look at our expression right here where we had, let me just copy these over here and just bring it on over for our purposes here. Quadrants 1 and 2 were covered. What about quadrant 3? Well, in quadrant 3, we use pi again, but in quadrant 3, what we're going to do is we're going to take our reference angle of pi over 6 and add that to pi this time. So pi plus pi over 6 gives us a standard position angle in the third quadrant. And so that is going to be 7 pi over 6. And as far as quadrant 4 is concerned, if we use pi over 6 as our reference, this time we compare it to 2 pi. So in quadrant 4, to get our angle, we're going to take 2 pi minus pi over 6 to get as our reference angle. And this will give us the value of an angle between 0 and 2 pi, whose sine would be negative 1/2. And in this case, that turns out to be 11 pi over 6. And so in this case, our 4 solutions include 7 pi over 6 and 11 pi over 6. And that's our process, more or less. We're just going to be looking to see what kind of values would satisfy that equation. And if we know something about a reference angle and we know something about our quadrants, we're usually able to find all the values that we need. Okay, more to come in the next video.